students, welcome to our brilliant channel Maths Nation. Dear students, in my last sessions we have discussed about circle. Today we continue with this. Today we discussed about some examples. Students, I have already told you only knowing theory is not sufficient. Please practice variety of questions. Do your exercise regularly and ask me your doubts in my comment box. Students, these questions, example 2. Find the length of a chord which is at a distance of 5 cm from the center of a circle of radius 13 cm. At first try to understand the questions. When you understand the questions, then can you draw the diagram. When you draw the perfect diagram, then can you solve the questions. That's why it is very important to at first try to understand the question. What the question says, what the question asks. The question says, find the length of the chord which is at a distance of 5 cm from the center of a circle. This is a circle. Find the length of the chord. AB is the chord of the circle, given circle, and the chord is at a distance of 5 cm from the center. O is the center of the circle, and the radius of the given circle is given 13 cm. We have to find out the length of the chord. Here given OA radius is equal to 13 cm, and OM distance of the chord from the center. Distance of the chord from the center is 5 cm. OM is equal to 5 cm, where OM is perpendicular to AB. OM is perpendicular to AB. And as we know that OM divide the chord equally, means AM is equal to BM, means AM is equal to half of AB. Consider the triangle OAM and recall the Pythagoras theorem. Here the Pythagoras theorem says h square is equal to p square plus b square. Here h is equal to 13 cm and p is equal to 5 cm, and we have to find out b. B is equal to h square minus p square square root. Then here this is 13 square minus 5 square square root, which is equal to 169 minus 25 square root, which is equal to 144 square root. This means 12 cm. Here we find that AM is equal to 12 cm. As we know that AM is equal to half of AB. AB means AB is equal to 2AM, which is equal to 2 into 12 means 24 cm. Here the length of the chord AB is 12 cm to 24 cm. Here AB is equal to 24 cm. This is the answer of the questions. Here in the question is given, find the length of the chord which is at a distance of 5 cm from the center, and the radius of the circle is given 13 cm. Okay. Then next question. Please students, do your exercises. And if any doubt persists, please ask me in my comment box. I am ever ready to clear all your doubts. Here the question says, in the figure, O is the center of the circle. Here the question says, O is the center of the circle. At first try to understand. Circle of radius 5 cm. Here radius of the circle is given R is equal to 5 cm, and OP is perpendicular to AB, and OQ. Here AB and CD are two chords. Here AB and CD are two chords. Here this is AB and here this is CD, are two chords given here. This is let us draw once again. Here the example, here example 3 says, this is the given circle and O is the center of the circle. AB is the chord and CD is another chord. Here AB is a chord and CD is another chord given, and OQ and OP are perpendicular distance of the chord. Here OP is perpendicular to AB and OQ, O is the center and OQ is the perpendicular of CD chord. Then here OP is perpendicular to AB and OQ is perpendicular to CD, and the radius R means OC and OA are the radius. Radius R is equal to OC is equal to OA is given 5 centimeter, and AB is parallel to CD and AB is equal to 6 centimeter given. Here AB is equal to 6 centimeter given and CD is equal to 8 centimeter given. Then determine the length of PQ. Means we have to find out PQ. What is PQ? PQ is equal to OP minus OQ. OP minus OQ. At first we have to find out OP minus OQ. At first we have to find out length of OP, then length of OQ, then we can find out the difference between OP and OQ. Then here consider the triangle OCQ. Consider the triangle OCQ. Now, and recall the Pythagoras theorem, as we know that. Consider the triangle OCQ, as this is perpendicular, this is right angle triangle, and in right angle triangle by Pythagoras theorem we know that h square is equal to p square plus b square. Here h is given, h equal to r is given 5 centimeter, and here CQ is equal to half of CD. Here CD is given 8 centimeter, half of 8 is equal to 4 centimeter. Here CQ is given 4 centimeter. We have to find out OQ is equal to OC square minus CQ square root, which is equal to 5 square minus 4 square root 25 minus 16 square root, which equal to 3 centimeter. Here we can find out that the OQ is equal to 3 centimeter. Let us find out the OP. Then keep it here. Keep this here and let us discuss about what is the length of. We have find out that OQ is 3 centimeter. We have to find out OP. Then let us consider OAP triangle. OAP triangle. In this triangle, as per Pythagoras theorem, here OA is given 5 centimeter and AP is equal to half of AB, which is equal to half into AB is given 6 centimeter into 6, which is equal to 3 centimeter, which is equal to 3 centimeter. AP is equal to 3 centimeter. Then OP is equal to O, as per Pythagoras theorem, OA square minus AP square root, which is equal to 5 square minus 3 square root, which is equal to 25 minus 9 square root 16 square root is equal to 4 centimeter. Here we find that OP is equal to 4 centimeter. We have to find out PQ. What is PQ? PQ is OP minus OQ. OQ is 3 centimeter. OP is 4 centimeter. Hence, PQ is equal to OP minus OQ, which is equal to 4 minus 3 is equal to 1 centimeter. This is the answer of the questions. Students, when you read the questions, at first try to understand the questions. Then according to questions, draw the perfect diagram. Then you solve the questions. Okay. Then next. Then the next question says, and try to do your exercise and ask me your doubt. Here another question says, in the this is a circle given here. The question says, example 4 says, this is the circle, and here OD is perpendicular to the chord AB. Here AB is a given chord. Here AB is a chord given, and O is the center of the circle, and OD is perpendicular to OD is perpendicular to the chord AB of the circle whose center, and BC is the diameter. Here BC is the diameter. BC, here this is B, and BC is the diameter of the circle, so that CA is equal to 2OD. Here join CA, then we have to find out that the question here AB is a chord, AB is a chord, and O is the center, O is the center of the circle, and OD is perpendicular to AB, and BC is the diameter, Then here we have to show that, to prove that, to show that CA is equal to 2 of OD. Here we have to prove that CA is equal to 2 of OD. Then solution. Here since OD is perpendicular to AB, here OD is perpendicular to AB, and the perpendicular drawn from the center to the chord always bisect the chord from the theorem, and this means OD bisects AB, which imply then D is the midpoint, and O is being the center in the midpoint of BC. O is the center and BC is the diameter. This means O is also midpoint of BC. Then look at here. Here D is the midpoint. D is the midpoint of AB, and O is the midpoint of BC. Since BC is the diameter and O is the center, this means O is the midpoint of a BC. And another conditions is also given here. OD is parallel to BC, and OD is parallel to BC. OD is parallel to AC. Here OD is parallel to AC. This means OD is equal to half of AC. Since the segment joining the midpoint of two sides of a triangle is half of the triangles. As you know from the triangles theory, the segment which joining the midpoint of two sides, here D is the midpoint and O is the midpoint. This segment join the midpoint of the two sides means this is half, and OD is parallel to AC as per the given conditions. This means OD is equal to half of AC. Okay, this means which shows that AC is equal to 2 of OD, 2 times of OD. Here we have to prove this. Okay, then proved, okay, then proved. Hence, let us discuss some more theorems. Here, students, as for these theorems, you should practice all your exercises and ask me your doubt. Let us discuss some more theorems. Here, the theorem says each chords of a circle are equal chords of a circle are always equidistant from the center. Here, the theorem says equal chords of a circle are equidistant from the center. Are equidistant from the center. Okay, this means here this is the circle, given circle, and O is the center of the circle, and A, B and C, D are two given chords. A, B and C, D are given chords of the circle, and these two chords are of, we have to prove that equal AB and CD are two chords of equal length, given that AB and CD, O is the center, are two chords, and AB is equal to CD. Then here the O is the center, and OM and OL is perpendicular distance from the center of the circle OM. Here OL is perpendicular to AB, and OM is perpendicular to CD. Here we have to prove that OM is equal to OL, means they are equidistant from the circle. Here we have to prove that OM is equal to OL. Then join OC and OA. Join OC and OA. O is the center. Join OC and OA. Proof. Join OC and OA and consider the triangle OCM and OAL. Then here edge OL is perpendicular to AB, and we know that the perpendicular from the center always bisect the chord. This means AL is equal to half of AB, and CM is equal to half of CD. As AB is equal to CD, this means half of AB is equal to half of CD. This which means half of CD, which means AL is equal to CM, and OA is equal to OC. Since radius, these are the radius of the circle. Since radius, and this is perpendicular, which implies that OMC angle is equal to OLA angle, right angle, then by RHS property. Keep it here. Then by right angle side hypotenuse. OA and OC are hypotenuse of these two triangles. Then by RHS property, these two triangles OAL triangle is congruent with the triangle OCM triangle. This means, which shows that OM is equal to OL by CPCT, corresponding part of congruent triangle. Then OM is equal to OL. We have to prove this. Hence proved. Then let us discuss the theorem 2. Theorem 2 is the just vice versa of theorem 1. Here the theorem 1 says equal chords of a circle are always equidistant from the center. Here the theorem 2 says when two chords are of equidistance from the center means these two chords have equal length. Theorem 2 is vice versa of theorem 1. Look at here. Here theorem 2 says the chords of a circle which are equidistant from the center are always equal of length. Chords of a circle. Here this is the circle given. Here the O. Here this is the. Let us look at here. Here the theorem. Theorem 2 says, let this is a given circle and chords of the theorem 2 says, chords of a circle which are equidistant. I have already told you theorem 2 is vice versa of theorem 1, which are equidistant from the center are equal of length. This means this is a circle given and O is the center of the circle, and here A, B and C, D are two given chords. A, B and C, D are two given chords, and OL is the perpendicular distance of chord AB from center O, and OM is the perpendicular distance of the chord CD from center O. Here given condition is given A, B and CD are two chords, and they are of equal distance from the center, where OL is perpendicular to AB and OM is perpendicular to CD, and as per the conditions OL is equal to OM, then we have to prove that AB is equal to CD. Length of AB is equal to length of CD. Then let us prove. Keep it here and let us prove. Then let us prove. Consider that, let us join OD and OB. Here join OD and OB. Then join OD and OB. Then consider the triangle OMD and triangle OBL. As we know that OL perpendicular to AB means OL bisect AB. This means BL is equal to half of AB. And here also, as OM is perpendicular to CD, it always bisects CD. This means DM. DM is equal to half of CD. Then here consider the triangle OBL. Consider the triangle OBL and OMD. Then as per the conditions, OL is equal to OM because they are of given and OD is equal to OB. OD is equal to OB as radius and OL is perpendicular and O to AB and OM is perpendicular to CD. This means OLB angle is equal to OMD angle is right angle. Then by RHS property, right angle hypotenuse side, right angle hypotenuse and side property. Then by RHS property, these two triangles are congruent. Then by RHS property, OBL triangle is congruent with the triangle OMD, which imply that BL is equal to DM by CPCT, corresponding part of DM by CPCT, corresponding part of congruent triangle. And as we know that BL is half of AB and DM is half of CD. This means half of AB is equal to half of CD, which implies that AB is equal to CD. Here we have to prove that AB is equal to CD. Hence proved. Then as I have told you, theorem 2 is the vice versa of theorem 1. Then today this much, students. Please subscribe my channel and press the bell icon to get the notification of the upcoming videos. Thank you, students. In my next sessions we will continue with this. Till then, happy learning.